we're moving on to theme A of the workshop today, and that's trends in AI and big data. And we'll first start with a presentation by Flavio Calvino from the OECD, who's going to give us a sense of the portrait of AI diffusion across countries of the OECD members, and after which we will have a presentation by Katherine Stapleton from the World Bank, who is going to give us some preliminary evidence on the diffusion of AI across emerging countries, and then give a much more closer look at what's going on in the country of India. Thank you very much.
Thank you very much. Thanks a lot for the invitation. Looking to the slides that can go up to the first. Indeed, thanks a lot. My name is Flavio Calvino. I'm an economist at the OECD. I'm going to present joint work with Luca Fontanelli from the University of Brescia about a portrait of AI adopters across countries, firm characteristics, asset complementarities, and productivity. And the usual disclaimer, the views expressed here are those of the authors and cannot be attributed to the OECD or its member countries. So let us start. We know we have seen AI as a strong potential, but AI is shaping very rapidly the economic landscapes. It can be considered a general purpose technologies whose application may increase the productivity of adopters, but little empirical work and little empirical evidence so far has comprehensively analyzed the patterns of AI diffusions across firms, especially at the international level, with like an outlook to a broad set of countries. While this would be crucial to better understand how to fully leverage the potential of digital transformation and the implications for the economy. So what I'm going to present here today is a novel outlook about this, and the aim of this paper is to draw a portrait of AI adopters, of users of artificial intelligence, firms using AI across countries. We're going to focus on firm characteristics. So who are these firms adopting AI? The role of complementary assets that are like intangibles, skills, or digital infrastructures that are factors that are key and complementary to the use of artificial intelligence, and the links between the use of AI and firm productivity. How we are going to do so? We are pioneering a distributed microdata approach in the context of the OECD AI Diffuse project, which is based on a common statistical code that has been developed by the OECD and is run on official representative firm-level surveys across countries in a decentralized manner. I'm going to get to the coverage in a while. This study focuses 11 countries, and just before getting a little more into the details, let me just summarize what are the key findings and the main takeaways of the analysis. What we see is that first, AI use is more widespread across large firms and to some extent across the younger ones. We see that the use of artificial intelligence is highly prevalent in sectors like ICTs and professional services. And we see that complementary assets play a key role for the use of artificial intelligence, and in particular, ICT skills, firm-level digital capabilities, and the use of other digital technologies, and fast digital infrastructure. We see that the users, that firms using artificial intelligence tend to be more productive than other firms, and these productivity premia tend to originate for the largest ones, although we see that these premia do not seem to reflect the use of artificial intelligence alone. In particular, complementary assets appear to play a critical role, with productivity advantages of AI users likely related in most cases to the selection of more digital and competitive firms into the use of artificial intelligence. So let me start a little bit focusing on the streams of the literature that this study refers to. I'll try to be brief on this, but evidence on the use of artificial intelligence by firms broadly focuses on 3 or 4 types of data sources at the microeconomic level. The first source of data, which is the one to which this study is more closely related to, is firm-level surveys. Official firm-level surveys that are run from statistical offices where firms are asked questions like, do you use artificial intelligence? And in this sense, there are a number of country-specific studies, especially focuses on the US, but also on Germany and Korea, that are addressing these issues. The second source of data that has been used in the literature relates to the online job postings. Postings of job ads that firms post online, hiring AI professionals or AI specialists. And again, here there is a little bit of literature, especially focusing on the United States, documenting the demand for AI-related jobs and skills, especially focusing on the US, but also to some extent across countries. We are working on this also at the OECD and on Finland. The third source of data is related to IPRs, patent and trademarks, and the extent to which they are able to proxy AI-related innovation. Again, a number of studies, especially focusing on the US, but also with a broader perspective. There are other studies that use other types of data. I'm going to mention briefly about two of those that we are carrying out at the OECD and that are highly complementary to the study I'm presenting today, which is based on firm-level surveys. One is using online websites, so information available in the website of companies, where we look at AI-related keywords in a firm website across 4 countries, and we see what type of keywords and what type of technologies are mentioned, and what are the characteristics of these firms that have AI-related online presence. And in that study, we are also able to look at universities. While the second study, co-authored with my colleague Lia Samek, as well as Maria Grazia Sfuicciarini and Cody Morris, we look at combining information from online website, on AI-related online job postings, AI-related Python. We combine all this information together and match it with firm-level balance sheet data from the United Kingdom, identifying and characterizing AI adopters in the UK, with the main findings which are broadly in line with what I'm going to present to you today, focusing on ICT surveys. So just to wrap up a little bit what is the existing evidence, we see that in the literature there is a positive association between the use of artificial intelligence and firm size. This may be related to fixed costs, to the scale advantages that where larger firms may be in a better position. However, there are more ambiguous findings on the links between artificial intelligence use and labor productivity. We see this before, and we see this a little bit more in one of the sessions in the afternoon, which I think is going to focus on this. But this lack of relation can be related to J-curve dynamics, where there are complementary investments in intangibles that take time to materialize and fully translate into productivity gains. We know, and we have seen this in the keynote, machine learning is a prediction technology, but prediction is only one part of the decision, and there may be time needed to get to more system-level solution. But there is also a very recent emerging evidence that focuses on specific AI applications, such as those related to generative AI, which tend to find more positive findings. What we do in this work, we take a cross-country perspective using official representative data from 11 countries, exploring directly not only the characteristics of adopters, but also the links with complementary and the role of complementary assets, and the links between artificial intelligence use and productivity. Let me say a few more words about the data and the methodology that we employ in this study. So the study is based on data from national statistical offices in 11 countries, which are listed in the slide. They are Belgium, Denmark, France, Germany, Ireland, for which we only have preliminary results, Israel, Italy, Japan, Korea, Portugal, and Switzerland. Information in these data sources, which are official firm-level surveys, they contain information on basic firm characteristics, such as the sector of activity, the age, the size, and the turnover, that allows us to build a proxy of labor productivity as a turnover over employment, as well as, importantly, for the purpose of this study, information on the use of technology by firm. The typical information here is based on questions that are asked to firms of the type, does your enterprise use any of the following artificial intelligence technologies? But there is information about more technologies that we use in the study, including other digital technologies such as cloud computing, ERP, CRM, or information related to digital infrastructure, in particular the presence of ultra-fast broadband, as well as ICT skills, in particular the presence presence of ICT specialists or training provided to employees, ICT training to the employees. The main features of this data is that they are representative of the population of businesses above a certain threshold, which is 10 plus employees, and there are ways available for most countries that allow us to compute weighted statistics. The coverage of the data is country-specific and ranges between 2017 and 2021, with the main definitions of artificial intelligence, which are harmonized in the European data, while vary a little bit in other countries. So how do we analyze this data? We propose a distributed microdata approach where we developed centrally at the OECD a statistical code which is then distributed to experts across countries that have access to the data, to which we are particularly thankful, and I see some of them here today, and they are able to run the code on the data and provide the output for the cross-country analysis. So it's a separate analysis for each country using the harmonized statistical code that we developed, the Diffusion code. We then carry out consistency checks on the output in collaboration with the experts, as well as validation of the metadata before integrating the data from each country in the whole cross-country project. And this builds on the experience of the OECD on other distributed microdata projects on business dynamics, productivity, and R&D. What are the main outputs of the AI diffuse code? They are related to summary statistics, and in particular, we're going to focus today on the shares of AI adoption, as well as other summary statistics, and then a number of distributed regressions, so regression that are pre-programmed and then run on the microdata, which we divide into adoption regression, which explain the adoption, the use of artificial intelligence, so with an AI use dummy on the left-hand side, and productivity regression, which have instead labor productivity on the left-hand side. So let's go a little bit on the findings of the studies. I'm going to start presenting some descriptive statistics based on the share of the adoptions, and then go a little more into the findings from regression analysis. So the first analysis facts I was mentioning at the beginning is that AI is more widely used across large firms. You see here, this is a summary figure that plots the shares of AI users by firm size class, and the size of the circle is proportional to the number of countries for which the relation hold. And you see that across the board, the size class that have the highest number of employees, 250 plus, is the one exhibiting the highest shares of adoption across countries. I don't know if we could click on the link in the slides just to give you an idea about the figures, how the figures look like. So this is what looks like when we look directly at the figures across country, and you see that across the board, the larger firms are those that exhibit higher share of adoption. We can go back to the presentation, but this may be consistent with the fact that large firms may be endowed or have better capabilities to use intangibles or other complementary assets that may be crucial to fully leverage the potential of artificial intelligence. Second fact, we look at the age of firms, and we see that to some extent, AI is more widely used across young firms. You see in the figure that the share of AI users are lowest among firms that have the highest age. In this particular case, you see the 11 plus firms, so firms that have more than 11 years, while share of adoptions appear higher for firms that have 0 to 5 or 6 to 10 years old, so among the younger firms. And this is consistent with the idea that startups and young firms often bring to the market more radical innovation, especially in the case when a new technological paradigm, such as the one related to artificial intelligence, emerges. Third, we focus on shares of adoption by sectors, and we see that across the board, across all countries, share of AI users are highest among ICT services and professional and scientific services. You see this in the slide, and this may be consistent with the fact that AI is still used more importantly in these sectors, while its potential as a general purpose technology may yet have to fully materialize. Then we look descriptively at the link between the use of AI and other digital technologies by focusing on a variable which is a proxy of firm digitalization, the number of digital technologies used by the firm. And we see that in every country, shares of AI users are highest among firms that use the highest number of digital technologies, suggesting that AI does not come alone, but is part of a digitalization process that occurs at the firm level with the technology that build upon each other. So this was a bit the purely descriptive part of the analysis. We're going to move next to some regression analysis to take into account the role of confounding, or the number of confounding factors and compositional effects by estimating type of models that have the AI use binary variable on the left-hand side, and on the right-hand side we have some size class dummies as was defined before, age class, and fixed effects identifying sectors, and upon availability, depending on for the countries for which we have more than 1 year of data, year fixed effects. What we see basically on the regression is that this regression tends to confirm the findings that we have seen previously from the descriptive analysis. And in particular, large firms are more likely to use artificial intelligence, and the likelihood to use AI generally increases with the firm size, and older firms, also conditional on size and sectors, tend to be less likely to use artificial intelligence. Here we could perhaps click on the regression table slide on the bottom side of the slide, if that is possible, to look at the findings, which are basically now here in the slide. And you see that if you focus on the coefficient for the largest size class, is the one that still is the most highly positive and significant, while the age class 11 plus is the one that tends to be negative, in some cases significant in many countries. We can go back to the main slide. Thanks a lot for the support, because the next set of the regression is going to explore the role of complementary factors for the use of artificial intelligence. And in particular, we look at a number of factors of complementary assets and the relationship between the use of AI across countries. These are, in particular, digital infrastructure, and in particular the presence and use of ultra-fast broadband or cloud technologies, digital and innovative capabilities, so the use of other digital technologies as a proxy of firm digitalization and innovative activity, human capital related variable, in particular the presence of ICT specialists or training, ICT training for employees, as well as internationalization. And here, if we click back on the regression table, we basically see that all these factors for which availability depends a little bit across countries, but the main point is that this factor across the board are positively related to the use of artificial intelligence after taking into account the confounding factors that we have mentioned before, highlighting and suggesting a key role of complementary factors in the framework of use of digital technologies, human capital, and digital infrastructure for the use of artificial intelligence. Thanks for going back to the main presentation, which then shifts looking at the link between the use of artificial intelligence and productivity. And so here we are going to explore the association and the links between the use of AI and labor productivity as proxied by what is available in the data, which is turnover over employment. Starting again from a descriptive perspective, we see that shares of AI users are highest in the highest quantile of the productivity distribution. Here we have built sector-specific quantiles on of the productivity distribution for each country, and what emerges is that there is this generally positive association between the quantile of the productivity distribution and the share of adoption of use of artificial intelligence. We go back and continue the analysis, moving to regression, focusing again on the links between AI use and productivity by estimating a simple regression model that has the log labor productivity on the left-hand side and as main exploratory variable the use of artificial intelligence, which we will also interact with the size class dummies, as well as controlling for size class, age class fixed effects, including sectors and year, where relevant, as well as a number of additional robustness checks I will not talk through about, but confirm the main findings. What we see when carrying out this exercise, this analysis, is that the users of artificial intelligence tend to be more productive. You see that in the slide where the green cell highlights a relationship that is positive and significant, and you see that it appears across most of the countries. We also see that these productivity premia tend to originate from large firms, and we see that when we interact the main artificial intelligence dummy with the size class dummy, suggesting here it's a summary results that suggests that these productivity premia tend to originate from the firms that are in the largest size class. However, these premia do not seem to reflect the use of artificial intelligence alone. Indeed, when we take into account in the regression model I was talking before the role of complementary factors on complementary assets, so when we control for those skills, digital infrastructure, the use of other digital technologies, and we add them into the analysis, we see that basically productivity premia of AI users significantly reduce or tend to disappear, while complementary assets remain positively and significantly related to the use of artificial intelligence, basically across the board, suggesting probably that these productivity advantages are likely related to a selection of more digital and competitive firms into the use of artificial intelligence. Here, I shall mention we have initial evidence of more direct effects beyond selection for one country for which we are able to access directly the microdata, which is France, for which we are carrying out ongoing work matching the ICT surveys with a panel of firm-level balance sheets, which allow us to control for productivity back in the times before artificial intelligence was used, and so analyze more precisely the role of selection, as well as carry out some more extensive exercise, even adopting an instrumental variable approach, which tend to suggest that for a group of users of artificial intelligence, especially those that develop their own AI algorithms, so AI developers, there may be more direct effects beyond selection of more direct productivity effect beyond the selection one I was just mentioning. So, probably time to start summing up with the main takeaways from this analysis. We have seen that the use of artificial intelligence appears to be more spread across large firms and to some extent across the younger one, and is prevalent in ICT and professional services. We see that complementary factors, complementary assets, including ICT skills and training, firm-level digital capabilities as proxied by the use of other digital technologies and the digital infrastructure, are key for the use of artificial intelligence by firms. We have seen that AI users tend to be more productive than other firms, especially the largest one, although these premia do not seem to reflect the use of artificial intelligence alone. Indeed, we have seen again that complementary assets, these complementary factors, appear to play a key role with the productivity advantage maybe related to the selection of more digital and competitive firms into the use of AI. And in this context, the role of AI strengthening the advantages of larger and more productive firms may imply widening gaps between the leading firm, the most productive firms, and other parts of the business population over time. And in this context, policymakers can play a key role to foster an inclusive digital transformation in the age of artificial intelligence by focusing on a broad policy mix affecting incentives and capabilities, focusing on different policy areas and policy levers related to human capital, such as boosting ICT and high-quality STEM education, improving managerial capabilities, focusing on digital capabilities, incentivizing digitalization, easing the financing of intangibles, supporting research and innovation, on digital infrastructure, which we have seen as important by reducing digital and connectivity gaps, and on framework conditions, reducing barriers for entry of new firms and barriers to grow, fostering competition and addressing regulatory challenges of the digital economies. This broad policy mix may allow AI use and its return to be more widespread across firms and sectors in the age of AI. This basically concludes my presentation. I just have one or two additional slides. I don't know if I have 1 minute just to mention that this work is very much complementary to a number of studies that we are carrying out at the OECD with a number of colleagues. This one is focused on ICT surveys, but we have been taking a similar perspective using different sources of data for one country, the UK, where we have been matching job postings, AI-related job postings with information from online website, with information on AI-related innovation from patent and trademark with balance sheets together, which finds in this study, focusing on the United Kingdom, the findings are very much in line with the polarization between young, small, and all large users, especially concentrated in the ICT sectors, and the key role of complementary factors, as well as another study where we focus on companies and universities that have AI-related online presence based on information available in firm and company and university websites. So this basically concludes my presentation. Thank you very much.
Thank you very much, Flavio. Very exciting presentation, some preliminary results on the diffusion of artificial intelligence across 11 countries, looking at the determinants of diffusion, as well as making some links with productivity effects. So thanks a lot for that. I did have one question that we got from online, so let me start with this. You alluded to it a bit towards the end of your presentation, but given the fact that you find results of AI adoption for the largest firms, those that are young, and particularly those with a lot of complements. From a policy perspective, what can countries do to further encourage adoption amongst those that are the smallest, those that are old, and those with the most vintage assets?
Yeah, that's a good question. I can perhaps go back and spend a little bit more words on the policy framework that we are suggesting. Basically, a number of complementary policy interventions addressed at different policy levels can allow fostering an inclusive digital transformation. I was talking at the complementarities between interventions related to human capital, skills. We have seen in the analysis that are one of the key complements that are positively related to the use of AI, as well as another key complement we have seen is the digital infrastructure, so reducing a digital and connectivity gap, as well as fostering more broadly the digital transformation by incentivizing digital transformation more broadly and easing the financing of intangibles. We've seen the third complementary asset, which was crucial, was the use of other digital technologies, as well as relevantly framework conditions related to allowing startups to enter and grow, reducing barriers in this sense and fostering competition.
Great. Thank you very much, Flavio. And then just one more question, and this was raised about the importance of complements, which I think you rightly stated in your presentation. It's something that Avi alluded to as well. And one of the things you mentioned is that data matters, cloud computing, flexible storing, and computing matters in digital infrastructure. Can you speak a bit on which one of these you think matters the most And then in terms of timing, is it something that these types of complements need to be in place as a prerequisite before adopting AI, or is this something that's happening sort of simultaneously through the adoption process?
This is it's a very good point. In this particular work, we cannot look too much at the timing. We see information occurring simultaneously. Although, based on the literature and hopefully on work that we plan to do in the future, I do think that timing is probably something that is relevant and would be great to further investigate, in particular because probably digitalization is a gradual process with some of the technologies, especially the digital infrastructure, which can be seen as one of the building blocks, with other more advanced technologies coming a little further. But it's not something that we can reply with the data I've been presented today, but I hope that we are going to carry out analysis in this direction in the future.
Thank you, Flavio. Okay, I think we can now open it to questions in the audience. So please raise your hand.
Brian Cahan. I wondered, I was a little concerned with the data on large companies, because that doesn't speak to whether AI is really central or where in the company it's located. Do you have any insights into that? And just concerned that's a little unfair comparing large companies with small companies, which may be very focused on AI, compared to large companies which are simply experimenting with it in one corner of the company.
So in this analysis, basically we take data on the representative data on the population of companies, and we try to see where share of adoption are higher. And we see, as I presented, a little bit of a coexistence between higher share of AI use among the largest companies, but also to some extent among the youngest one. In one of the additional studies I've been referring to, so here we do not cross-tabulate the two dimensions, also because of confidentiality issues. But in one complementary study that we have carried out on the UK, we see a little bit of a polarization between some users that are young and small. So these are the startups that are using more intensively AI, and that they have also higher AI intensity. They use more intensively the technology. And another part of companies that are the largest and the older one that probably exploit artificial intelligence algorithms related to their current production process. I don't know if that answers a little bit your questions, but I hope it goes in a good direction.
Anybody else?
Yeah, I'll raise one then. Thanks, Flavio. This is really good. I did have a question. You mentioned all these facts like the firms using AI are large and so on. And we know that from even basic technologies in the past to do with IT in general and servers, that the firms that tend to use them tend to be large and have other complementary, IT skills and whatever. Is there any way of you comparing, are these particularly big, say to earlier technologies or big data use in general rather than AI? Is there any way you can quantify that roughly?
I think that's a very good point. We haven't done so, and there are some challenges in this particular work, given the way in which the data are collected, which are collected in cells to try and minimize confidentiality concerns. But it is a very good point, and we will keep it in mind while broadening the focus on other digital technologies, which is a little bit what we have in mind for the next steps of this project. And you're right, would be good to see a little more in this direction.
Great. Thank you very much. Let's give a round of applause to Flavio.
Thanks again for the invitation.
And next up is Katherine Stapleton from the World Bank.
Sorry. Okay. It's a pleasure to be here today. My name is Katherine Stapleton. I'm an economist at the World Bank. and I'm presenting joint work with colleagues at Oxford and the fund, and actually my colleague Alex is at the back and can take questions as well, and is a co-author on the paper. So today we're going to talk about AI in India. So as a motivation, so AI obviously doesn't really need introducing in this type of conference, but what really motivated this paper was the fact that India has seen very rapid growth in AI. And so on the left, we've taken a look at the rise in demand for AI skills in online job adverts. And what we found is AI has really taken off around the world, but India has been one of the countries that's seen the most rapid growth over the past few years. Despite this, a lot of the research on AI has focused instead on high-income countries, but there's interesting questions for developing countries, particularly those that have followed a services-led development model, like India, that are in an earlier stage of their growth model, and what this means for their future path. Reflecting the fact that there has been relatively little empirical evidence, particularly on developing countries for AI, there have been fairly polarized views on what this will mean. So on the left-hand side, we've got Paul Krugman, who has been arguing that AI is probably a bad thing for countries like India because it will reduce outsourcing of, say, medical work. Likewise, we've got Koronek and Stiglitz hypothesis, which is that AI is likely to be bad for countries that have comparative advantage in lower skilled labor. But on the right-hand side, we've got a very different view from Richard Baldwin in his book, where his view is that forms of machine learning, like machine translation, are actually going to increase offshoring to countries like India, and so India could be a beneficiary. What we're going to do in this paper is ask specifically how AI is affecting firms in India. And what we're going to do is we're going to take the starting point of using job adverts from India's largest jobs platform. And we're following a wide literature in measuring the diffusion of AI using the demand for skills as measured in job adverts, following the work of Daniel Rock, James Harrigan and co-authors, and Darin Acemoglu, and even Avi, and a growing number of people who are using job adverts data. What we're first going to do is look at how AI has diffused in India's firms, regions, industries. We're then going to measure the causal impact of firms hiring machine learning engineers and related roles in India on their demand for other skills. And we're going to do so using two different methods. One is a shift-share design, and the second is a propensity score matching event study design. And so what we find, as mentioned first, is we've seen very rapid growth in the demand for AI skills. And this has been particularly, similarly to Flavio's research presented before, highly concentrated in IT and finance in India. And what we find in this paper overall is this is really a high-skill story. So in contrast to previous waves of technological change, which generally led to hollowing out of middle-skill occupations, what we're finding here is the negative effects are for higher-skilled occupations, particularly managers, and particularly specific tasks like description, forecasting, research, and prediction. But by contrast, we see a positive impact for lower-skilled occupations and for routine work. So it's really a story of negative implications for the highest skilled and potentially a decline in inequality. But overall, within the firms we're studying, and we're studying non-AI producing, so this is not tech and not education, but in firms that are using AI, we're finding negative effects overall within those firms of them hiring more machine learning engineers, and negative effects on wage growth. Then I'll just start with a few clarifications of what we're looking at here, because it's quite specific. We're focusing generally on machine learning, so we're going to be looking from 2010 to 2019, so this is pre-ChatGPT times, unfortunately, as we don't have the data up until then. And so this is really machine learning as opposed to wider artificial general intelligence. And we're also looking at job level exposure and within firms. And we're looking at postings, so we only have postings data sets. So these are wage offers and not wages that we'll be looking at. So to start with the data that we're working with, this is data on online job adverts from India's largest jobs platform that has asked to remain anonymous. And they estimate they have around a 60% market share, so it's around 60% of job adverts in India. And this is predominantly white-collar urban work. Of course, being in India, the formal labor force is relatively small. And we, in contrast to other scraped online job adverts data, one benefit here is this platform. Any firm that wants to list a job advert on their platform has to plug in their information into a standardized template. And so we have nice, consistent data on, say, wage offers, which firms are required to put, and tagging of different categories that firms need to select when they plug their job advert. And on the right, this is an example of what this might look like on the platform. So what is this covering? So job adverts data, of course, is only job adverts posted online, and those job adverts are skewed. So what we find is this is really over-representative of the IT and professional services in India. So we're really talking about the urban, predominantly white-collar services industries. And we're keeping only services and dropping manufacturing. So in terms of measuring the demand for machine learning within job adverts, so the idea here is, in an ideal world, we would have excellent firm-level data of the extent to which firms are deploying AI and what they're using it for. In the imperfect world, we don't have that, and we particularly don't have that for countries like India. So the idea is, if a firm is hiring a machine learning engineer, there's a reasonable chance they're doing it because their firm is starting to use machine learning in some way. So we're really using it as a proxy. And we justify this. Well, there's a wide literature now doing this, but one justification is when there have been firm surveys asking firms when they start using machine learning how they do it. Do they hire external consultants? Do they train up staff within house? What most firms are saying is they hire new talent in order to execute the machine learning operations they want to. And thus, we think it's probably a reasonable proxy. And here's one example, an algorithm engineer. So this is the kind of information we get from it, the description, the location, education requirements. And so what's nice is, as text data is so rich, we're able to extract anything that relates to machine learning and tag this post as a machine learning related post. Then, in addition, as we're interested in really understanding the demand for granular tasks within job adverts, we take a few approaches. We use the standard classifications of routine, non-routine, abstract. But we also extract the verbs specifically and use a classification that's been used by Ferdinand Rao and colleagues, which classifies tasks into understanding the types of work or the types of activities these involve using Roget's thesaurus. So we'll use that in the analysis subsequently. So what we find in terms of the machine learning job adverts in India, they're more likely to have words like develop, build, program, design, and they're less likely to have verbs like call, account. So on the left, recruit. The left is the ones they're less likely to include, the right is the ones they're more likely to include. Unsurprisingly, the occupations that are including AI skills, highly likely to be software developers or data analysts, as would be expected. Then moving on to some facts about what's going on in terms of AI demand in India. So quite similarly to in research for other countries, big increase as we would expect in IT and software. But in India, particularly, it's financial services that we're seeing rapid growth, although also slightly volatile growth. And interestingly, in contrast to the kind of hypothesis that this was going to have negative implications for BPO and call centers, we actually see very little demand for machine learning skills in the BPO industry. Also, very similarly to research for the US, so I think Avi has a similar paper where he looks at the demand, the premium for AI skills, we find there's a strong premium for AI jobs, and that's even when you control for occupation, many other fixed effects. The salary premium is around 13%, which I think is quite similar to the premium that's been found in the US. And postings that include AI skills are more likely to be higher skilled, higher earning jobs. Also, perhaps unsurprisingly, this is highly concentrated in Bangalore. So our job adverts data is already overrepresented in Bangalore, but jobs including AI skills are particularly likely to be in Bangalore. And there's only a few spatial clusters in India, which are accounting for a very high share of all these AI job adverts. So which is helpful when we get to the results, these results we're finding, it's really a Bangalore and a Mumbai story. Then similarly to Flavio's research, we're finding that these vacancies are highly concentrated in the largest firms. And we also find evidence of agglomeration effects and spillovers in diffusion in the industries and regions that have had one firm posting AI postings are more likely to then subsequently post more. And that's particularly the case for the software industry. So then turning to actually the estimation of effects. So here we're trying to understand the causal impact of AI on labor demand within the same firms that are hiring machine learning engineers. So the first question is, what would we expect to see? So I think, as we know, there's a now pretty wide-ranging literature trying to understand all of the complex impacts of AI. At the most simple level, the conceptualization that AI is the task of prediction. There's therefore the direct implication that tasks involving prediction could be displaced. But of course, there's also the wider implications in terms of declining productivity and positive impacts on labor demand. There's also a wider literature on AI as a general purpose technology, with AI being the method of invention. And thus, there's many reasons why we would expect the positive effects to probably outweigh the displacement effects. So what we're going to do specifically here is we're taking a long difference shift share specification, where we're looking at the impact of AI demand in firms on growth in hiring. And we're using the exposure, the baseline, using the patenting level AI exposure measures of Webb. And we'll also take various other measures in the as robustness checks. So the idea here, and we're taking a two-stage least squares approach. So the idea here is if a firm has a higher share of occupations in the beginning, pre-AI taking off, that were highly exposed in terms of their task content to being automated using AI, then we'd expect that those firms are more likely to start hiring AI engineers, realizing their tasks could be conducted using AI instead. So these are tasks or occupations like civil engineers and actuaries have high exposure scores. And so we're then instrumenting for growth in the demand for AI skills within each establishment by this baseline exposure measure and controlling for various fixed effects. And so what we do find is firms that are highly exposed ex ante do see a substantial increase in the demand for AI skills within establishments, particularly for the very most exposed firms, whereas firms that are showing limited exposure are not increasing hiring of AI-related roles. And the first stage is strong, and AI exposure is predicting demand within the establishments for AI skills. So then, sorry, that skipped through. When we look then at the causal second stage impacts, so what's the impact of a firm hiring AI engineers on the postings for non-AI related roles? We're finding a statistically significant negative impact. And this is also holding for all vacancies. So the positive impact of hiring AI-related roles is being outweighed by the negative impact of seeing a decline in demand for non-AI postings. When we look at which occupations this is impacting, it's these two occupational categories of professional occupations and managers, which are really driving this effect, particularly the managers category. And when we look within the managers category, it's this one on the second to the right, which is corporate managers that are seeing the most strong negative decline. In terms of routineness, as I mentioned at the start, this is a story of declining demand for non-routine tasks and potentially increasing demand for routine tasks, except the story for routine tasks is less clear. Then coming to the task content of these job adverts, what we find is there's a strong negative effect, particularly on this one category, which is titled intellectual faculties, which is particularly these three categories of precursory conditions, so work that's related to research, also means of communicating ideas, words related to narrate, describe, then also to some small degree is extension of thought, which includes words like predict. We find this also holds even when you look within the top 1% higher paying roles. So when we think of the negative implications for corporate managers and understanding why we're seeing a decline for corporate managers, seems it could be related to lower demand for these specific skills that corporate managers would typically be conducting. Then in terms of wage growth or wage offer growth, so this is the wages as listed in the job adverts, we find negative impacts on the median wage growth and overall, again, with the positive impact for AI outweighing, the negative impact outweighing the positive impact. What we see is this shift in the downward distribution, but when we look in terms of holding the occupational composition fixed, what we find is a lot of this result is just from a change in the occupational composition of who's being hired, with the firms hiring less higher skilled roles and more lower skilled roles. But we find weak positive effects for the top 1%, suggesting even for the highest paid roles that we're seeing a decline in the wage growth for these occupations. And again, it's really the corporate managers who are the ones who are being negatively impacted here. So then taking stock, what we found so far is firms hiring more machine learning engineers has a negative impact on their hiring of other roles and a negative impact overall. And we're seeing a change in the occupational composition where these firms are then hiring less high-skilled and more lower-skilled roles. And we're also finding within occupation effects for these groups of corporate managers in the top 1%, we're seeing a decline in the wage offers and a decline in the task content of what they're doing, with less demand for these activities like forecasting, researching, narrating, describing. Then, similarly, as this was previously, these results were all along different specifications, so that was the growth from 2010 to 2019. We also wanted to look at what's happening in between this time period, so what's happening immediately after firms are hiring machine learning engineers. So for this, we take a propensity score matching event study approach, matching AI adopters with similar non-AI adopters, following a few papers in the literature. So this is the event study specification with a fairly standard specification. And what we find is in the immediate interim, as firms hire, they're increasing their overall hiring. But then very quickly, these results materialize after 1 year and then are strongest after 3 years. So this isn't just a longer term effect, but this is happening in quite short term after the hiring happens. And then we've done various robustness checks, most important, of course, being shift share robustness, where we're seeing our case for causal identification here as from the exogeneity of the shares, following the Goldsmith-Pinkham approach, and we show there's no evidence of pre-trends, and those tests generally show robustness of these results. We also try and look at, instead of the job adverts data, instead labor force survey data from the NSS and PLFS, where we find fairly similar results. So to sum up, the conclusions of this paper, we're finding quite surprisingly negative implications of AI in these non-tech industries, but mainly for higher skilled work, but positive implications for lower skilled workers. So then the question is, what are the implications here for development? We started out with this question of services-led growth, thinking and the hypotheses at the beginning of Krugman and Koronek and Stiglitz that this was going to have negative implications for countries with comparative advantage in lower skilled labor. Appears that this isn't particularly the case with India. It seems more negative implications to the higher skilled workers. But of course, lots of questions remain over whether that matters. Does this matter that there are less higher skilled jobs? Of course, higher skilled jobs are generally better jobs everywhere. So within these firms, these negative consequences for this type of work, we need further work to really understand the extent to which that matters. But of course, we caveat here, this, of course, there was to some degree a negative story, but as we said, this is non-tech industries. So at the same time, you're obviously seeing a very big increase in probably high-skilled jobs in the producing industries of AI, and these are only in the ones that are consuming, so it could well be shrinking of one, or negative implications within firms in one sector and less so in the others. We also, when we look at the district level, we don't find any statistically significant effects, suggesting this could be netted out elsewhere. But also very surprisingly similar findings to various papers in the literature for the US and the UK of these negative implications for higher skilled work, and less so for slightly lower skilled work, like Michael Webb's paper and a few others. So I'll stop there and look forward to questions. Thank you very much.
Okay. Do you want me to take the clicker?
Oh, yeah, sure.
Thank you very much, Katherine. I think that was an excellent research presentation on the diffusion of AI in India. I'd start with any questions from the audience. If not, I've got about, oh, please, go ahead. No, after you. Go ahead. Go to the audience first.
I'm sorry, I just wanted to ask two questions. One, your final point about what you said, AI producing and AI consuming. What do we know about how much in-house AI skill is needed, and typically what are the tasks performed in-house, and how much is AI as a technology which is off the shelf, procured from AI purchasing firms? And the final question I had was, were you able to disentangle the scale or substitution effects of changes in employment?
Shall I answer?
Yes.
Yeah, so to the first question, so this question about are firms, to what extent do they hire a machine learning engineer versus to what extent do they use off-the-shelf tools? So you might not, is that correct? Yeah, so I think that's really the crucial question that we don't know is the answer to, but I think the research of many people in this room who are working directly with firms can come at that question. What we did was just looked at all of these like McKinsey type studies, people who've run studies with firms, and asked them how are they using AI. But of course, like now with tools like ChatGPT, you could see many people would be able to use AI to a higher degree now than they would have 1 or 2 years ago because of those tools. But I think our thinking on this is, given this is up to 2019, maybe those tools like TensorFlow and PyKit and these things, anyone could pick up and work with them, but you probably still would hire a machine learning engineer or someone with at least reasonably strong software skills or understanding of algorithms. But we can't say for sure. And on the second question, scale, which affects disentangling?
If it changes total factor productivity and makes a firm more competitive, the firm expands, versus the substitution effect of replacing one worker by another.
Yeah, so we are as our only data set here is this online job adverts data. We don't have the data on their balance sheet, so we're not able to look at productivity. Although we've now tried to match to the Indian census data to get more information on that. But so we're only able to look at whatever they put on this platform. So it's just their job ads. But what we are finding within the firms is these positive impacts of hiring machine learning engineers as being outweighed by the negative impact of hiring less of everyone else. So it does look as though the displacement effect, the substitution is outweighing the creation. But of course, that's only within the firm. And we don't know, maybe then slightly down the line, they become more productive or they're positive. There's probably a story of rising demand elsewhere in the economy and, say, the tech industry. And maybe what we're picking up here is just finance and professional services. But we want to look into that more because I think that's really crucial.
So I'm thinking about one of the comments Avi made about the centralization of decision making. And I'm thinking here, when you mentioned establishment here, but you've also used firms. I mean, are you able to see different effects of managers, say, in the headquarters versus in the, say, branches, the other sites of the firm? Is it like economies of scale in management? So now you have one super good manager at the headquarters and you don't need them all in the little plants. And so can you distinguish the within firm, sort of the headquarter versus other sites?
Yeah, I think this is a really good question and something we wondered ourselves. So in our data, because we only have establishment level information, so we can't actually link them back as far as I'm aware, but we are trying to actually link them together with firm by extracting the firm names. And then we could look at that, and then we would really like to look at this because I think this is really important because it could be, that what we're picking up is the one establishment of this multinational, but actually its headquarters is expanding and they hire less corporate managers. So hopefully once we've got the firm name matched linking version, we can then answer that question.
Yeah, I think just building off of that, there obviously is a substitution effect away from certain types of occupations or tasks to others. And similar to what John said in Avi, there's this importance in decision making and the fact that artificial intelligence is doing a better job of that. I guess within the text data from the online postings, you could identify, say, tasks around decision making and see whether or not there's any link between that and what you find.
Yeah, so I guess then we could look at, so when we see this declining demand for corporate managers, whether we see elsewhere that there's but I guess it's hard to get at what the machine learning is being used for. But this was something I've long thought that there might be ways to understand when they describe roles. They often talk a little bit about like, this is going to be used for X or Y to get more at what it's being used. But it would be interesting if you could see that it was being used for centralizing decisions or like creating automated ways to make managerial choices, which does sound like a reasonable hypothesis.
Great. Do we have any other questions from the audience? If not, we're going to take a coffee break for those that are in person, and for those that are attending online, you can join back again at 11:40, where we will have session B, which is on firm reorganization and AI. Well, we will have a talk first by Yav Bonaviv from Harvard Business School and Jonathan Timmis from the World Bank. Thank you very much.